Okay, so now we're going to look at applying our linear equations into linear models. So remember, a linear equation is a line. Lines have constant rates of change. So when we're looking at real life situations, we want to model with lines if we have a situation that has a constant rate. And in a line, it's the slope that tells us rate. So we've got slope is rate. We also have in a line, if we've got a line in slope-intercept form, our y-intercept is the starting value. So we've got a y-intercept is our initial value. That's when x is 0. The x-intercept, when y is equal to 0, that's when whatever we're measuring with our rate is finished or ends. So if we think about a general linear model, we have the y value is equal to the rate times the x value plus whatever the initial value was. Initial. So this is my y-intercept, and then I have my rate times my x. Now, normally with real world situations, we're not going to use y and x. We're going to use the independent variable and the dependent variable, and normally we're going to write it as a function because our dependent variable is a function of the independent variable. So let's try it with this example too. We've got Jackson starting an exercise program on the day he starts. So day he starts, this is our initial value, is 15. He then increases his time by 2 minutes each day. 2 minutes each day is our rate. So we've got minutes on the exercise, minutes on the treadmill is dependent on what day it is. So write a function, time of day. So how much time on the treadmill is a function of what day it is. We've got our time measured in minutes, depending on the number of days. So let's write down our initial thing. On the day he starts, so day 0, my time was 15 minutes. And now my rate is 2 minutes per day. So that means that my slope is 2. This is my y-intercept, and so that then is my c value. If I think of y equals mx plus c. So let's write down my equation. Time as a function of day is equal to 2 times the day, so slope times independent variable plus the initial value. I could have started with these two values and said originally my equation is my linear equation, y equals 2x plus 15, and then I could have translated that into my variables that this problem is based on. All right, now that I have the function, how many days Jackson has to exercise before he's spending more than 30 minutes on the treadmill? So I want the time on the treadmill to be greater than 30 minutes. So my equation for time, this is the answer. I need to know what day, so I want to use my equation. 2d plus 15 greater than 30. Subtract 15 from both sides. That is also 15. Divide both sides by 2. That tells me that my days must be greater than 7.5. So therefore, on the 8th day, he exercises more than 30 minutes. Make sure that in word problems, we always answer with a sentence.